The derivative is, we just talked about, it's the slope of the tangent line. We just gave it a new name, the slope of the tangent. We gave it a new name, and we called it derivative. Well, let's think about what that means as far as the definition of derivative then, a formal definition of the derivative. So we know the notation here is f prime. So we're going to define here, write out an equation for the definition of the derivative. Good news. We've talked about the slope of the tangent line, and matter of fact, we came up with two different equations, if you will, for the slope of the tangent line, didn't we? We saw that it was, by definition one, we found that slope that it was with a limit. It was the limit of those secant line slopes. But we also used the equation 2, which kind of did it different. We used the h and made the h go to 0. Well, if that's the slope of the tangent line, then thus, that's the definition of derivative. The definition of derivative is going to be that very, so here's what we had. We're going to use equation 2 preferred, okay? So let's just refresh our memory. The slope of the tangent was, by definition 2, m equals the limit as h approaches 0, and we call it f of a plus h minus f of a over h. That was equation 2. Remember that? Just talked about that. Well, derivative is the slope of the tangent. Thus, this gives us a definition for derivative. Now, in this particular case, instead of using a for the x value, we're just going to call it x. And that's kind of why we use equation 2 here, because it's really just switching x's out for the a's. That's what we're going to do here. So the definition of derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. Look familiar? Yeah. It's basically what we called equation 2. So that's good news. We've done some of these already. We're just now going to call them derivative instead of slopes, but that's what they are. They're going to be slopes still. Now let's kind of try not to lose sight of what this is. It's again the slope of the tangent, but where does this come from? Why was that the slope of the tangent, and so why is this then our derivative? Well, you remember what this is right here? That's just slope of a secant line. So let me draw just kind of a generic example here. So what this is giving me, what this gives me, I'm looking for the derivative at x. So I'm looking, here's my x value. Here's my, and that's my point then. And so I'm looking for the slope of that tangent line. That's going to be the derivative. Well, what does this give me? That gives me the slope of a secant line. If I go out h units from that x, so I'm going to kind of exaggerate, I probably wouldn't go out this far, but if I go out h units from that, that puts me at x plus h, which puts me at this point. Okay, so what does this give me? It gives me the slope of this line, doesn't it? That's the slope of that line. Well, if I put the limit on it then, limit as h goes to 0, so if I bring this h value closer and closer to 0, what that's going to give me then is this tangent slope. And so that's what we call then the derivative. It's graphically same thing as we were doing there. Just now we're calling it derivative, okay? So that slope equals the f of x plus h minus f of x over h. This is the derivative now, and that's the slope of the tangent line, which is the limit as h approaches 0 of that. You see, that's how we find that. Because we're drawing that h in. As we draw that h in, the secant line slopes get closer and closer to the true tangent line slope. So, thus is the derivative. Right? Okay. Keep that in mind. That's where we got all that. But good news again is we've done these. We're just now going to do them in the context of what we call the derivative. So let's do a couple practice again. All right, so let's find f prime of x using the definition. Number one, f of x equals x squared minus 5x plus 4. All right. Well, by definition, f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. This is the same as we were doing in the previous section there, or before we took test 1 there. Just now, instead of using a's, we're using x's. Same idea. So how do we do that? Well, f of x plus h, that means input x plus h for x. X here, x here. So both of those, for f of x plus h, both of those are going to be, let's go down here. So we got the limit as h approaches 0. F of x plus h, so I'm doing x plus h in for x. So it's x plus h squared minus 5 times x plus h. Because that x gets x plus h, and then plus 4. So this right here is my f of x plus h. From that, then, I subtract f of x, and my recommendation is let's put it in parentheses, because that being behind the minus sign, that's going to change the signs of all those others. So it's going to be minus parentheses f of x, which f of x is just that, x squared minus 5x plus 4. And that's all over h. That's the limit I need to compute. This is f of x plus h. This is then f of x. So I've got my limit to compute. And so that, we use the same techniques as we've always done here. Best thing would be to go ahead and simplify the top part out there. X plus h squared. You got to full it out, or you know the shortcut, but x plus h squared is just x plus h times x plus h twice. Nothing else, just full that out. X times x is x squared. X times h is plus xh. H times x plus another plus xh. And then h times h is h squared. And so what you've got is x squared plus, those two are the same, so it would be 2xh. 1xh plus 1xh is 2xh. And then plus h squared. So that is what this first part is. X squared plus 2xh plus h squared. All right, then for the minus, you've got to distribute the minus 5, so it'll be minus 5x minus 5h. And then don't forget that whole plus 4 there. And then, like I said, this minus here is going to change those signs. So it'll be minus x squared minus 5x minus 4, right? Plus 5x. Plus 5x will change signs. And that's all over h. So what happens? Usually then nice things should happen. If they don't, then you might want to check everything. Yeah, the x squared is minus and plus 5x, 5 plus and a minus 5x, and a plus 4 and a minus 4. Everything cancels out except this, that. But the good news is the ones on top all just have an h, or they all have an h in them. So we can factor off the h, and it cancels out the bottom h. So factor h off of this leaves me with 2x, an h, and then a minus 5. Is that right? But yeah, then that allows me to cancel the h's out, which I didn't start there, but that's why I can't compute this one right from the beginning, because h goes to 0, so the denominator is 0. That usually happens when we do these limits. So we got to somehow get rid of it. Ta-da! Now we can. Now we can do h goes to 0. The h goes to 0. So this derivative is, we would say, 2x. It's f prime. In this particular case, f prime is 2x minus 5. Okay? All right, now, let's do this one. Find f prime of a for f of x equals 1 over 3 minus x. F prime of a for f of x equals 3 minus x. Typically, we're wanting to find f prime of x. I think in the first section, part of this homework here, it wants us, first of all, they want us to compute f prime of a. We'll ultimately want f prime of x, but what this means, if I want f prime of a, f prime of x is this, so f prime of a would be, go back to the a's for x's. So it's the limit as h approaches 0, f of a plus h minus f of a over h. So you just make that adjustment. Just make the x's a's. It's the same thing. Which that's really more what we were doing prior to this, but anyway, just a little fine detail. All right, so f of a plus h, what does that mean here? Well, a plus h is the input. So that's going to be what the x is there. Now, it's minus x, so if I do, let's do it this way. So that would be 3 minus parentheses a plus h. Minus, then f of a, so a goes in for x, so it would be 1 over 3 minus a. That's over h. So f of a plus h is 1 over 3 minus parentheses a plus h, minus f of a would be minus 1 over 3 minus a over h. With me? Yes? Okay. All right, so we've done, again, h goes to 0. Can't quite substitute in quite yet. The way we did those, get a common denominator. So the common denominator is going to be this denominator times that denominator. I'm going to write it down. So if I need this times that to be the denominator, then the first one I need to multiply by 3 minus a over 3 minus a. And then the minus 1 over 3 minus a, well, it's going to need the 3 minus the a plus h, top and bottom. If I write it all out there, it's kind of long, but yeah, so that's going to give me, if I look at the denominators now on top, that gives me a common denominator, so I can combine numerators. So it'll be 3 minus a. A little tricky here, so let's write it this way. It'd be minus 1 times 3 minus a plus h. Matter of fact, let's go ahead and make that a minus a minus h, because that'll make the distributing there. And then the denominator will be 3 minus a plus h, or let's go make that a minus h. It's 3 minus a. Over h. Okay, so we combine the tops, I guess simplify it just a little bit, distribute that. So it'll be 3 minus a, minus 3 plus a plus h. Over 3 minus a minus h times 3 minus a. And at some point, I'm going to go ahead and do it here. This is divide by h, so it's times 1 over h, the reciprocal. That's what that means. But good things start to happen. The 3's cancel. Minus a plus a, those cancel. Take each other out. So up here on top, all I now have is h. But again, I've got that factor of h right up there. That cancels, doesn't it? So the top's just 1. Now the bottom I can let go to 0, h go to 0. So what do we got on the bottom? That's 0, so it's 3 minus a times 3 minus a. 1 over 3 minus a squared. That's my derivative, f prime of a. We've done similar before, so we're just kind of renaming it as the derivative, but it's the same processes as we've had before. Question? All right, try this one. Again, they'll just use different terms, but if it's derivative, it means the same. So let's find g prime of t. For g of t equals the square root of 3t plus 2. All right. So we switched it up a little more here. But I'm still finding the derivative, right? It's g prime, that's the derivative. I now just have to use g instead of f and t instead of x. So that's what changes over there too, do the exact same changes over there. So g prime of t, what's it going to be? It's the limit as h approaches 0. Well, instead of f, I've got g, so it'd be g. Instead of x, I've got t, so it'd be t plus h minus g of t over h. So just make those little conversions there, same thing. Using the definition. Again, that's what we're doing here. Got to use the definition. You know, any shortcuts? Not yet. Can't do any shortcuts yet. Using the definition here. So what's this going to work out to be? Well, same thing. For g, I'm going to input t plus h. So that goes in for the t right there. So it'll be the limit as h approaches 0. So g of t plus h would be the t replaced by t plus h would be the square root of 3 times t plus h plus 2. Right? Minus g of t. Well, g of t is square root of 3t plus 2. And then over h. That's our limit that we need to compute. Well, we know little tricks or techniques, I guess better term for it. How do we do such, h goes to 0, so denominator 0, can't substitute yet. What's the trick here? Conjugate? Use the conjugate. I'm not going to rewrite it all. Let's just multiply by the conjugate here. So the conjugate, that square root plus that square root, that's a conjugate. And you can distribute the 3 there if you want. The top and bottom, multiply by that thing right there. Because when I do that, the top turns out pretty nice. All right? So the limit as h approaches 0. So yeah, the reason it turns out nice, this times this, the square roots go away, so it's just 3. That's right, it's 3t plus 3h plus 2. I'm going to distribute the 3 there. Middle terms drop out because you got that square root times that square root, and then you got a minus. Very same thing, so those are going to cancel out. And then that times that. Well, it's going to give me a minus of 3t plus 2. Careful with your signs there. Plus and plus, so you got a minus, and then the square roots cancel one another out. So it's that. Over square root of, h. H times that conjugate square root there, 3t plus 3h plus 2, plus the square root of 3t plus 2. You can rewrite it by distributing that to what's going to happen. I guess we'll put it right down. All right. So if that minus gets distributed there, so it'll be 3t plus 3h plus 2 minus 3t minus 2 over that h times square root of 3t plus 3h plus 2 plus square root of 3t plus 2. Okay. Yeah, that minus makes those both minus. So the 3t's go out and the 2's go out. Now we just have 3. Or 3h. But that h and that h, since everything else is gone, I can cancel those h's out, can't I? Let me rewrite it. So the top's just going to be 3. Now the bottom, I can make h be 0 because the bottom no longer is 0 if I do that. But h goes to 0, so isn't that the square root of 3t plus 2, that first one, because the h is 0, plus then square root of 3t plus 2. That's 2 square roots of 3t plus 2 on the bottom. That's our derivative. 3 over 1 square root of 3 plus 2 plus 1 square root of 3. That's 2 square roots of 3 plus 2. That's my derivative. G prime of t. Yes? Is that okay? Question or concern? Just got to proceed through it. It's a lot of little things. Be sure to get all those little things correct, otherwise it screws you up a little bit. That's kind of the rub on these. You've got so much to keep straight. But. All right. One more of these, and then I'll talk about a little something else. Okay. And this is kind of the wording I think they have in a homework problem. So, all right. So let's find f prime of 3 for f of x equals x cubed minus 8, and use it to find the tangent line at x equals 3. Find f prime of 3 for f of x equals x cubed minus 8, and use it, use word there, use it to find the tangent line at x equals 3. Well, do what you want. I'm just going to go ahead and compute f prime of x, and then this is just saying plug in 3 for that, because it might ask me for another one, the same problem or something like that. But so yeah, let's just find f prime of x, and then we'll substitute f3 for x. So f prime of x, by definition, again using the definition, can't use a shortcut yet. So limit as h approaches 0, f of x plus h minus f of x over h. And you could plug in 3 for x at this point. It doesn't matter, but I'm just going to go ahead and do f prime of x, and then I'll do the 3. All right, so that's the limit as h approaches 0. So f of x plus h means input x plus h for x, so that'd be x plus h cubed minus 8. And then minus f of x, so minus f of x would be minus parentheses x cubed minus 8. Right? It's just minusing x cubed minus 8. Divide by h. Okay? All right. I guess there's multiple ways we could go at this, and if you got another way, that's okay. As long as you get the same, as long as you get the correct answer, say it that way. Typically, yeah, what we do is let's go ahead and cube that x plus h out. So that'd be x plus h times x plus h times x plus h. That's, I'm doing x plus h cubed. Might have to do that at some point, so let's talk about that. Well, just do these two, which if you do those two, you get x squared. We just did it, but you got an xh, x times h, that's xh, and then you got an h times x, that's xh. You got 2xh there, and then you got h times h is h squared. But then you have to multiply all that times another x plus h. Well, it's kind of FOIL extended, let's call it. X squared times x is x cubed. X squared times h is x squared h. Then we do the 2xh times those, so it'll be 2xh times x, that's 2x squared h. And then 2xh times h is 2xh squared, 2xh squared. And then we take the h squared times those two, so it'll be h squared times x is h squared. And then h squared times h is h cubed. And we do have some nice common terms here. You got x cubed, x squared h, 1x squared h, 2x squared h, that's 3x squared h. 2xh squared, 1xh squared, that's 3xh squared. So that's the cube of x plus h. X cubed plus 3x squared h plus 3xh squared plus h cubed. Then we got the minus 8, and then we got to distribute, so it'll be minus x cubed plus 8. One way to do this. We cube it all out and then bring those others down. Well, some nice things do happen. I've got an x cubed, and I've got a minus x cubed. And I've got a minus 8, I've got a plus 8. So all that's left is those three right there. But they all have an h in them, so I can factor off that h. So it'll be 3x squared. And I'm pulling h off of that, it'll be 3xh plus 3xh. Pull an h off of that would be h squared. And then I can cancel off my h, so I factored it off. Yeah, so now, no longer is it a problem to plug in h to be 0, right? H is 0, so what do we got? 3x squared, 3x times 0, that's 0. H 0 squared is 0, so I've got 3x squared. That's f prime of x. This particular case, first part of it anyway, though, I was wanting f prime of 3, and that's what I was saying. I did it just kind of in general terms, because now, give me any x value you want, and I can calculate f prime. In this case, it wants f prime of 3, so f prime of 3 would be what? 3 times 3 squared, 27. That's 3 times 9. So f prime of 3 is 27. With me on that? Yes? It's okay. Question? That's f prime of 3. Second part, use it to find the tangent at x equals 3 now. All right? What information does that give me? I've got f prime of 3 is 27. What does that give me about the tangent line? What does the derivative stand for, graphically speaking? Well, it's what we were calling slope of the tangent, isn't it? So f prime of 3 equals 27 means that 27 there, that's going to be the slope of the tangent at x equals 3. That's the slope of the tangent at x equals 3. So my equation of the tangent, so my tangent line, it's a line, so it's y equals mx plus b. That's the slope, isn't it? This derivative I found, it's the slope of the tangent. So m is 27. I just need to figure out the, oh, yeah, all right, yeah, so finding, that's, I think it just asks for the slope, but it's asking for the tangent line. Now I just had to figure out what b is. Well, to figure out what b is, remember the way we did it is we used the xy combination. I've got the x value is 3. What's the y value though? If x is 3, what's y? Well, y is just the function value at 3. So y would be 3 cubed minus 8. That's 27 minus 8, which is 19. So I've got x is 3, y is 19. That'll be my plug-ins for x and y here to find the b. With me? So 19 is y with the x value is 3. Oh, okay, so that's going to be quite a large negative number. Is that 81? 27 times 3? So b would be 19 minus 81, negative, what was that, 62? Negative 62 is b. So it's, the tangent line is y equals 27x minus 62. Just plug in the minus 62 for the b.